Welcome to Nanomedicine lecture. Let me introduce myself. I'm Dr. Rinat Letfulen, professor at Roshalman Institute of Technology. Also, I'm professor at Radiological Technologies University. This is my contact information. Also, I have a web page. I'm doing research over 25 years, and I'm doing research in the 4 or 5 main areas. One area of my research is laser physics, including super high energy lasers. Another area of my research, optics, including quantum optics, wave optics. Another one, biophotonics, including nanomedicine. And last one is nanotechnology, including the optics of small particles, nanoparticles. I published about 150 papers and conference proceedings, and 12 book chapters in 10 different books, and each book corresponds to my main area of research. Also, I am editor for International Journal of Theoretical Physics, Group Theory and Nonlinear Optics. Let me discuss new technological frontiers in the 21st century. In the last century, we did the many discoveries in the physics, microelectronics, high-speed communication, transportation, but these discoveries were made in the last century. What is new directions in the science and technology in the 21st century? You probably heard many times that the trademark of the 21st century is a nanotechnology. But besides the nanotechnology, many developments going in biology, information, environment, energy. And speaking about the natural sciences, we have 3 main technological frontiers: nano, bio, info. And the nanomedicine combines 2 of them. Nano and bio combines the nanotechnology and biotechnology. Nanomedicine is a new science, is a new technological frontier. What is a nanomedicine? Let me give a most general definition of the nanomedicine. Nanomedicine is an interdisciplinary science which involves the many sciences like physics, chemistry, biology, medicine, optics for diagnosis and treatment of diseases by means of nanotechnology. The ultimate goal of the nanomedicine is to treat the human body at the molecular, at the atomic level, like we're fixing conventional machines today. Key word in the definition of the nanomedicine is nanotechnology. What is a nanotechnology? You probably know about that. Word nano came from Greek letter and it means something small, dwarf. When we say nano, we mean 1/1000th of something. Nanometer, 1/1000th of meter. 1/1000th is a 10 in -9 meters. So a nanotechnology or nanoscience is interdisciplinary science which investigates the object in the size range from 1 to 100 nanometers. And in this size range from 1 to 100 nanometers, object behaves completely different from the bulk materials. It has unique properties, unique functions, and that's why the nanoscience and nanotechnology studies these unique properties, unique functions, and developing new applications. Nanotechnology is booming right now. If we will look on the world market today, world market will spend in the next 10-15 years about $1 trillion in the nanotechnology area, and we need about 2 million specialists working in this area. This money will be spent for material development, nanomaterial development, nanoelectronics, pharmaceutical companies, chemistry manufacturer, aerospace engineering, and many others. This slide demonstrates how this $1 trillion will be distributed. Speaking about the application of nanotechnology in the medicine, the most applications will go to the oncology and fighting the most important disease, cancer. Let me discuss in more detail how nanotechnology can help the medicine today. If you come to the clinic today, the clinic can offer you different imaging and treatment modalities like radiography, fluoroscopy, mammography, computed tomography, nuclear medicine, positron emission tomography, magnetic resonance imaging, chemotherapy, magnetic field treatment, microwave and radio frequency treatment. These modalities have some positive outcomes and have advantages. And what kind of advantages I see here? First of all, they allow us to deeply penetrate inside the body. They allow us whole body scan, like shown on the right side of my slide. They also allow us slice scan to see the specific organs and specific position of the organs or tumor. Fast scan, the whole body scan actually takes less than 1 hour. They give the information about the position of the organs, density information, boundary and the structures of the organs. We can clearly see the position of the organs, boundary of the organs, and see the density information. And these modalities allow us for diagnosis and treatment of big tumors. Under big tumor, I mean the special resolution of these modalities. The most modalities have a special resolution 1 millimeter and bigger. It means they can see the tumor 1 millimeter and higher and bigger. 1 millimeter tumor already contains the 1,000 of the cancer cells. That's why I'm calling this tumor big tumors. And another advantage, these modalities extend the patient life. Besides these advantages, these modalities also have some disadvantages, and let me list a few of them. Today's modalities are unable to detect and to treat the disease at the single cell level, at the DNA level, and we know, for example, that the cancer is a DNA mutation disease, and today we cannot see the mutation of single DNA. That's why diagnosis and treatment becomes late. We have metastasis and are unable for selective treatment. If we see the tumor, what we're doing, we're using chemotherapy or radiation therapy, and we're damaging the healthy cells. It's not selective treatment. And even if we're using X-ray radiation at the therapeutic doses can cause the secondary cancer. Unable to treat effectively bone cancer and marrow, and marrow is responsible for immune system of the human body. So when the cancer reaches the bone and the marrow, patient eventually dies. Unable to complete cancer cure, reoccurrences occurs after the treatment, and patients eventually die. And one more disadvantage, this treatment procedure very expensive. These machines, multi-million-dollar machines, and the treatment is very expensive. So how we can solve these disadvantages, how we can solve these problems? And nanotechnology, nanomedicine offers the decision for these problems. Nanomedicine is a future medicine. It can detect and treat cancer or another disease at the single level, at the DNA level. That's why diagnosis and treatment becomes earlier. There is no problems with the metastasis. It's a selective treatment. Only tumor will be treated with this way. Healthy tissue will not be damaged. There is no side effects in the nanomedicine. So nanomedicine can solve many different problems and improve the medicine today. This slide just gives you some ideas about the application of nanomedicine today. There are many applications, but this table consists of only few of them, like improving imaging, drug delivery, DNA analysis, selective nanophotothermolysis of cancer, implant materials, artificial tissue, improving brain, cleaning teeth, lungs, and arteries, nanorobots. In this lecture, there is no time to go in all applications of nanomedicine. Let me only describe one of them, a selective nanophotothermolysis of cancer. What is that? Nanophotothermolysis is a selective thermal killing of cancer cells by means of nanoparticles activated by the radiation. How does it work? First, we have to deliver these nanoparticles and attach to the cancer cells only selectively. To do that, we have today many delivery methods. For example, physiological transport technique, where the nanoparticles injected in the bloodstream, and they have a small size, and they freely fly around the body, penetrate through any organs, and can be collected at the cancer site. to collect them only at the cancer cells and at the cancer tumor, we're using antibody technique, conjugation to antibody. We're covering these nanoparticles by specific antibodies which will stick only to the receptors of the cancer cells, like shown on the figure below. After delivery of nanoparticles, we're activating them by using the radiation. It could be laser radiation, could be microwave radiation, could be radio frequency radiation. And under activation, I mean we're initiating different cell killing mechanisms like a thermal ablation, bubble formation, sound generation, shock waves generation, explosive evaporation, even optical plasma. And all these effects will kill the cancer cells and the tumor. Let me demonstrate this idea of this technology in the short video. This technology can be used for diagnostic purposes, but also for the treatment. And it can be used for any type of diseases, not just for the cancer. In this technology, we are using different types of nanoparticles, metal, magnetic nanoparticles, or polymer. Then we're covering these nanoparticles by antibodies, then injecting these nanoparticles with antibodies into the bloodstream. And the size is small, they can easily penetrate through any organs inside the body, and the antibody will search for the cancer cells and for the tumor. And then antibody will stick to the receptors only of the cancer cells, not the healthy cells like that. Then we can collect the right number of nanoparticles by making incubation time long enough, so we can collect the nanoparticles. Then we can use the radiation like that, scan the body with nanoparticles inside, and by using radiation we're activating these nanoparticles. And due to activation we can see and diagnose the cancer. Also we can treat the cancer and kill the cancer cells. And this technique have the few benefits listed here. This is a briefly main idea of this selective nanophotothermolysis technology. So where we can get the education in nanomedicine? Radiological Technologies University in Indiana in the United States offering for the first time in the nation a master degree program in nanomedicine. Radiological University is opening the campuses around the world, and recently we signed the agreement with Kazakhstan and opening the RTU campus in Kazakhstan on the basis of semi-state university and semi-state medical university. This will be a dual diploma program. One diploma will be issued by Kazakhstan University, and another diploma will be issued by RTU in the United States diploma. This is a 2-year master degree program. First year the students will study at the Kazakhstan at the semi-state university or semi-state medical university, and the second year the students will study in United States at the RTU Florida campus. We're offering 2 nanomedicine programs at the Kazakhstan campus. One master degree program purely in nanomedicine, and this is a 2-year program with 2 3-week clinical rotations, and table contains the core courses of this program. And another one is a dual degree program in nanomedicine and medical physics. It's also a 2-year program, master degree program with 2 3-week clinical rotations, and the table contains the core courses of this dual degree program. We prepared the brochure, flyers with information about these programs. Also, these flyers and brochures contains our contact information, description of the program. You're welcome to contact us directly to RTU or directly to me and ask any questions about our programs or ask the information about our programs, and we will be happy to provide you with this information, and we will be happy to answer on all your questions. In conclusion, I would like to say that the nanomedicine is a smart medicine, is a future medicine. Why? Because it provides the fast and the painless treatment. How fast? Remember we told about the activating of nanoparticles by radiation. We are using ultra-short pulses, picosecond pulses, femtosecond pulses. Femtosecond means 10 in minus 15 seconds. This is a very short, too short amount of the time, so the human body nerve system doesn't react on the too short amount of the time. That's why the patients will not feel anything during the treatment. That's why it's a painless and the fast treatment. Nanomedicine will provide early diagnosis at the single cell and DNA level, which is very important because the cancer is a DNA mutation disease. No metastasis, since it's early diagnosis and treatment, metastasis problems will be solved. Bone cancer treatment can be done by using nanomedicine. And I believe in the future, nanomedicine will defeat the cancer for good and give the life for the cancer patients. Thank you for your attention.